but it's 0 over 0. So maybe we should cancel some term out. That should reflect right away on conjugates. That's the only way we can cancel things with square root. Note, there was a plus here, so we should use minus here to match it. Similarly, here's a h, here is, ooh, should be a minus. Somehow I don't feel right. Oh, because I copied the wrong thing. Now I feel right. Okay. Now keep in mind, the reason you are trying to times the conjugate is because you have a minus b, a plus b. They become the square of each other. So this becomes this squared minus this squared. Now square root square, they cancel each other. 14 squared is 196. Now you notice these two numbers cancel each other. There is only a h on the top. There is a h on the bottom. We can cancel them safely. This time we plug in. The trouble is not there anymore. Well, over 28. So the key is the conjugate. The rest will be algebra. If you still kind of feel shaky on your algebra skills, you need to polish it. You are going to use it for this class. You need it, okay? And if you ever pursue in calculus 2 and 3 and later, you have to be really solid on your algebra. Otherwise, you won't be able to follow the lecture. Okay. Any more questions regarding this one before we move on? All right. Austin, what do you have?
2.1, problem 3C.
Give me a second. 2.1, problem 3C.
Yeah, to get the
Oh,
the
the last
equation
one.
of a tangent line.
Okay, let me see this. So here's the thing. 2.13C, you have a point P2 ln2 lies on the curve y equals ln x, no problem. And the q is x ln x. Now what you're looking for is you want to find the slope of the second line PQ. Which is ln x minus ln2, the difference between the y, divided by x minus 2. That's the slope. Okay. And then for C, you use the slope here to find the equation of the tangent line to this one. Okay. You have a slope, you just need a point, right? And the point is going to be 2 ln2. Because you're trying to find the equation of the tangent line to the curve at P. Therefore, you should use P. Then the formula becomes y minus ln2 equals k x minus 2. Now, the only thing you need to do is you need to replace this one by the slope. I understand the slope is for the second line, which is PQ, but when you have P, you should really take this one with a limit as x goes to 2. That is what you calculated in B, the guess, 0.5. From B. You did everything before to guess this value. Sounds good. Where is it? Justin? Austin? Does this make sense?
Yeah, that does. Thank you.
Awesome. Okay. Any other questions from the homework? Cool. So like I said, if you have questions, no matter it's the web work, homework, or anything, bring them to class so everybody can have a chance to see more examples. Okay? Of course, if you think it's minor, you can always bring it to my office hour, which is 1 to 3 today. All right. 2.2, 2.3, we defined basically limit x goes to a, fx equal to L, and then we did some calculation using loss or whatever. Okay. In 2.4, what we want to do is we want to give the precise definition of limit. Okay. For some of you, this section may seems tricky. Okay. But this is really a peak to high level math. This is how high level math is done. It's not about numbers or shapes. It's about logic and language. Okay. So just take it for fun, even though sometimes you may find it hard to understand. Take your time, absorb it. Okay. Now let's go back to the definition. We did have a definition. We say this means fx goes to L as x goes to A. That's kind of vague. Then we try our best. We can probably formalize it to be fx can be arbitrarily close to L, as close as you want, if x is close enough to A. Okay, think about the logic. What do you want? You want the limit of fx is L. That means your fx can be as close to L as you want. Given that x goes to A, which means given that x is close enough to A. Make sense here? Okay. That's good. That matches our common sense. But now we claim it's not precise. What do you mean by not precise? Well, you have some vague term there. What do you mean by arbitrarily close? How close is arbitrarily close? 0? Not 0? 0.01? How close is arbitrarily close? We don't know. We just feel like it's small. We have a feeling, and if it's the feeling, it's not objective, it's subjective. What do you mean by close enough? How close is enough? With respect to what? In which sense? Can you see there are some vagueness here? Even though it makes sense in common language, it's not something we want in mathematics. We don't say, hey, 2 plus 2 is almost 4. What do you mean by almost? What do you mean by very? Okay, that's something mathematicians hate. Therefore, now what we want to do is we want to make it precise. Or in another word, we want to change qualitative comments to quantitative. Okay, it's a very simple thing. Like you're a good person, that's qualitative. You're good, you're bad, that's qualitative. But you are a good person with a level 3.449, that's quantitative. So in this way, you can compare a good person. Okay, you can give a number, you can give a level, you can give something solid to what you just said. That means quantitative. You want something you can compute and compare. Good. Now let's see how we say this. Well, I will use an analogy. Let's assume we have a really good ruler manufacturer. who is specialized at making 1-inch ruler, which is exactly 1 inch long. Okay. Of course, he could never make something exactly 1 inch long, right? It may be like 0.1 inch off. That's a pretty bad one. But it may be 0.00000001 off. But again, he will never be able to make something exactly 1 inch. He will be off. Good so far? Now, how can you say this manufacturer can make something as close to 1 inch as you want? And you want to put a quantifier on it. How do you know that he never stops at 0.99 and could stop improving? He could always improve to as close as you want. How do you show that? And this is my thinking process. I'm going to talk to him. I say, hey, I want something 1 inch. Do you want to take the order? He said, yes, I'm going to take the order. How much is it? I'm going to take $20. All right. Then I take the ruler. I find, no. You didn't give me 1 inch. You gave me something 0.99. That's not 1 inch. I'm looking for 1 inch. So you are this much plus or minus 0.01 off. He said, oh, I didn't know that. I can make it better like this. But you have to pay $200. Good so far? No, I'm still not happy. I want something 1 inch. I don't want nothing to be this off. I want something better. He said, well, if you pay $2,000, I can make it even smaller. Okay. Now, what about something extremely small at 1 nanometer? He said, wow, this is not going to be cheap. You need to give me $2 million. I don't know why you want to pay me that much, but if you want something that accurate, this is what you pay me. Good so far? Now question. ... How do you know that he never stops? He can be as close to 1 as you want. Given that, you have to have unlimited budget because you know the more money you need to pay. How do you know that he could always continue? Okay, that's a tricky question. I claim if he can give me a complete price tag on every single arrow. Make sense here? He tells me for this one, $20 million. For this one, more dollar. Okay? But the good news is for anything, you know this table never ends, right? This table just keep going. The limit is 0, but you never end. But for every single one, you just pick out maybe something 10 to the negative 18. And you can always give me a price tag, no matter which one you pick out. I don't know, $2 billion? Okay. Then I am confident that he can do anything. He can be as close as I want to 1 inch at the cost of I have to have a really, really big budget, infinite budget. Make sense so far? If up to any accuracy, he says, okay, I stop here. I couldn't improve anymore. That means everything after that, he does not have a price tag. Starting from there, anything below that, there's no price tag. Then I claim he's a flaw. He's a fraud. He cannot make it that thing to be as close to 1 inch as possible because he has a limitation. Good so far? Okay, so this is how we are going to do this. What we're looking for is, given an arrow, we call it epsilon, we could always find a price tag. Which is called delta. For any epsilon, there is always a delta. Then I say, then you're good. Because if I name epsilon to be 10 to the negative 9, you give me a price tag. For anything I name, you can give me a price tag. And I have unlimited budget. Then I believe this thing eventually can be done. Sounds good? Okay. Now let's go back to limit. What do you want? You want fx and L are super close. What do you mean by close? That means they have a distance. They have an arrow, and that arrow is given by epsilon. Okay, you want fx minus L is less than that. That's what you want. What's the price you are willing to pay? You're willing to let x to be as close to A as possible. Okay, that's the price you pay. We name it x minus A is less than delta. Okay, now how small do you want this? How close do you want these to be? That's quantified by epsilon. How close is x to A? That's quantified by delta. Good so far? Now name an epsilon. You want them to be this close? Then as long as you can let these two be this close, that will happen. You want this one to be this close? Well, as long as you let this one to be closer than before, this will happen. Still okay? Keep going. For every single epsilon, I can have the corresponding delta. I have a complete price tag. It doesn't stop somewhere and say, from here, I couldn't have delta anymore because no matter what I do, this epsilon won't be smaller. Then you're done, right? So if for every epsilon, I can always find this delta, no matter what epsilon you pick, no matter how small it is. In that way, we say the limit is L, because you can be as small as you want, because you can pick any epsilon. I will always make it happen. Sounds good? Let's write it down in English. And this is how we say it. Let me write it down. The precise definition of limit x goes to A, fx equals L. And this is how we say it. For any epsilon bigger than 0, there exists, or say we can find, a delta such that if x minus A less than delta, then we can guarantee fx minus L is less than epsilon. This means close enough to x This means arbitrarily close to L. Oh, close enough to A. This is called talking about fx. This is called talking about x. Take some time to read it and raise questions. Okay, Eddie, I may ask you to mute your mic. We're hearing you typing. Yep, thank you. Does this statement make sense to you? Okay. You claim fx minus L can be arbitrarily close to each other, right? That means fx minus L is arbitrarily close to 0. That means you are close to each other. Okay. What do you mean by arbitrarily close? You say pick any distance. I'm smaller than that. Okay. Given that x is close enough to A. What is close enough? As long as you're close enough than delta, you're guaranteed. That's what we mean close enough. I tell you how close you need to be, given the particular epsilon. That's like the price tag. Sounds good? Okay. So this is a dynamical process. What do you mean by the limit is L? What do you mean by they're arbitrarily close? And your response is, give me how close you want. And I will tell you how close my X is going to be A will beat that. Give me anything, I will tell you how to beat it. Then you trust me, I can beat anything. I can be as small as possible, as you want, right? So it's almost a process like name an epsilon. I will tell you what the delta is. If I can do that, I can beat any epsilon. Sounds good? Emmett? Yeah, please go ahead.
I was gonna type it in the chat, but I'm sorry, I really don't understand what the difference between an epsilon and a delta is. Like
Oh, that's a good start. You know they're different, right?
I mean, they should be, I guess.
Great. Okay, that's a good start. So that means they're quantifying two things. Think about it. We are trying to say fx is arbitrarily close to L, right? Translate that thing is basically saying fx minus L less than epsilon for any epsilon bigger than 0. Good so far?
Yeah.
Okay. This will happen given that X is close enough to A. Can you see that? These are two different relationships. This is between fx and L. But in order to make it happen, you need to have X to be A and A to be close.
Okay,
That will be X minus A is less than delta. Good so far?
Yeah, I think so. Yeah.
And you don't have to let X to be arbitrarily close to A, even though you can. You just need to make it close enough such that this happen. Then you can stop there, because anything smaller than that, of course, it will happen.
Oh, okay. So like in the I'm sorry, like in the 1-inch ruler example,
Yep.
can you explain what the delta and the epsilon would be there, just so I can?
Epsilon will be the error, and delta will be the price.
Oh, okay. Thank you. I think I get that a little better.
Yeah, it's almost like you're arguing with people, right? You don't want to argue with people. One way to argue with people is just make general statement, but the other way to argue with people is just you name one, and I'm better than that. Right? That's how I beat you, right? It's just like, okay, name one, and I'm better than that. Then you say, okay, I want to name another one. I say, okay, this is my. Then you have a different answer, right? This is how I beat that. Then you say, okay, I name another one, and then you say, this is how I beat that.
Yeah.
Then you get tired. You say, just name a general one. Okay, make it X, and let me tell you how I beat X. Name it epsilon. Let me tell you how I beat epsilon. Just do this. Okay, then I beat you no matter what you raise. Whatever challenge you raise, I'm going to beat it because you raise a general challenge which is called epsilon. And I know tell you how to beat epsilon. My method depends on epsilon.
Okay. I get it now, or at least I get it better than I did before. I have another.
That makes sense now, right?
Yeah, I think it does. Yeah.
Yeah. What's the other question?
Like, am I actually supposed to be doing any homework for this class, or because all I've been doing are watching the lectures?
Did you join this class like after the first day, maybe something? So you missed the syllabus. Read the syllabus. That's the requirement there. But basically, what you need to do for the grades, except for the exams, are web work and writing projects.
Okay,
I will send
sure.
emails for every single writing project on when it's due, whenever it's ready. And for web work, it will always be due on Saturday. And you may not be in that system if you join the class later. So just go there, try to log in as the syllabus set. And if you couldn't, send me an email.
Okay, thanks.
Yep. Okay. Does it make a little more sense to everybody now? That was a very good question, by the way. So this is how you fight with other people. You argue with other people, just like name one, I'm going to beat that. Name one, I'm going to beat that. And this guy just keep annoying you by naming different things. You say, okay, forget about it. Name epsilon. That represents for everything you're going to raise from now on. I'm going to tell you how to beat that according to what you raised. Then go and figure out yourself. I don't want to spend time here with you to argue with you anymore. You know how to argue with yourself now. Sounds good? Okay, that's how we do it. So let me write it down. It's actually here. Let me circle it. That would be the precise definition of what you mean by limit x goes to a, fx is L. Basically now, for now, all you need to do is you just need to find out this delta for any epsilon. If you can do that, the argument is done. Okay, this thing self-generated itself. Let's try example. Okay, now let's say you want to prove limit x goes to 2, 3x is 6. Okay, what do you want to really prove? You want to prove for any epsilon, 3x minus 6 is less than epsilon. It's smaller than anything you can find. Of course, that's what we call limit is 6. Good so far? But that doesn't happen automatically. This will only happen given that x is close enough. So we were going to write this down. There exists a delta such that if x is close enough to 2 with this delta, then 3x minus 6 will be closer than epsilon. For any epsilon, there's a delta. Then I just proved that it works for anything. Of course, you need to tell people what this delta is. Okay, to show there exists one. You just tell people this is how we find it. Okay, so now let's start with what you want. You want this for any epsilon. Your final thing look like this. And you want this to guarantee this happen. Okay, you want to know what delta is. Now with the simple algebra, you can factor things out. You have this one. By dividing 3 on the other side. Then, through computation, you know this will happen if we let delta equals epsilon over 3. Okay, so I just proved it. For any epsilon, this will happen if x minus 2 is less than epsilon over 3. I just found that delta. For any epsilon, you claim there exists a delta, and this is the delta. And of course, it depends on epsilon. The smaller the epsilon, the smaller the delta, the harder to beat this epsilon. Sounds good? Let's see what we just figured out. What if I want epsilon to be 0.1? I want 3x minus 6 is less than that. That means they're close, not so close, but close. Then you just say, you just let your x to be this close. Sorry, let me write it down carefully. X minus 2 less than delta. Then you just let your x to be this close. which is roughly 0.03. This will guarantee that you will be no further than 0.1 from 6. What if my epsilon is this? You just let x and 2 be closer, which is roughly. What if you want to beat this? You just let this one divide by 3, whatever. Okay. What if I want this for whatever epsilon? You just let your delta to be epsilon over 3. So for each arrow, you have the price tag, and the whole table is complete. Then you can say, well, seems like the limit should be 6. Sounds good? Okay. Emmett, go ahead.
Oh, sorry, I just forgot to take my hand down.
Okay.
I
Yeah.
apologize.
No problem. All right. Okay. That's it. That's all for this section. Take some time, absorb it, rewatch the lecture if you want. Okay. Several things I want to point out. Number one, this section is the first time you encounter something which is called rigorous mathematics. When you go to high-level math class, you will find it's not about calculating numbers, doing shapes. It's all about doing logic in precise language. You will find everything they say makes sense, but they say it in a really clunky way, but everything is precise. Nobody says things like this in real life. For any epsilon, there exists a delta or something like that. Nobody says things like that. The problem with common language, in real life is just it's vague. It has a lot of confusions there. So different people will interpret it differently. For example, get your homework done before Saturday. What do you mean by that? Does it mean that Friday midnight is okay? Or does it mean also Saturday morning is okay? Okay, different people have different understandings, right? So what's the better way of saying it? The better way of saying it is get it done before Saturday, 5 o'clock. That's way better. But then as a mathematician, they will get confused. Does it include 5 o'clock or not? Because I can do 5 o'clock, do I consider to be late? Because do I have to do 4 o'clock and 59 minutes and 59 seconds? That will be okay, but 5 o'clock is not okay. So when you listen to a mathematician say stuff, they will definitely say something, get the homework done before 5 o'clock on Saturday, including 5 o'clock. Okay, it's totally non-human to say stuff like this, but that's what you need to do with mathematics. You have to be really, really precise. Okay, so it's kind of not the same as common language. That's why it's taking you a little while to absorb it. But trust me, it's great. It's great once you get it. Second thing is, if you're going to go into high-level math, no matter how hard it is right now, you should learn this lecture and make sure that you understand what I'm talking about. Make sure you feel comfortable talking about things like this. And if you figure that thing excites you, talk to me. You find it fascinating, you should talk to me, because that means it's very possible that you will like to be a math major. Okay? Number 3, of course, let's get down to the ground. Exams and homeworks. What's my expectation? My expectation will be, number 1, you need to be able to express the precise definition, which means you need to recite the precise definition. the question will look like this. Write down the precise definition of limit x goes to 7, 3x squared is, why do I do that to myself? 147. Your answer should be, okay, for any epsilon less than 0, there exists a delta such that if x minus 7 is less than delta, then 3x squared minus 147 is less than epsilon. This will be the answer to the question I just raised. And in the exam, you will receive something like this. Okay, I do not ask you to compute, but you should know where to put which number in this definition. Second, given an epsilon, I will ask you to find delta, which means the calculation we just performed. But this one will only show up in web work, not exam. Okay, so that's the expectation for how well you should understand this section. Because after this section, we will never use it in our class. Okay, so it's kind of like a standing alone to give you a peek of what real high level math is about. All right. Any questions regarding to our plan for this section? Addie?
I just have a clarifying question.
Mm-hmm.
So we'd only have, for this concept, we'd only have to find the solution on web work, but on the exam, we would have to do the precise definition like you just said.
Yeah, then on the exam, it will be a question almost exactly the same as this one, except for I'm going to change the thing here.
Right, okay,
It's going to be a different limit at a different point, but you need to know what to put there.
sounds good.
When I say calculating, that means finding delta equal to epsilon over 3. That's what I mean by actually find the formula of the delta.
And that would only be in web work.
That will be only be in web work.
Thank you.
All right. Cool. That's it. That's all for precise definition of limit. It may feel weird, but now if you think about it, it's pretty interesting. When you translate everything from that thing to epsilon delta, by the way, sorry, this is called epsilon delta language. We talked about this before. Is h 0 or is h not 0? What's the limit? We always find it's hard to talk about. So how does mathematician talk about it? They use exactly this language because they find the limitation is not in your mind. The limitation is in the way we speak. Okay. So now for any epsilon bigger than 0, there exists a delta such that if x minus a is less than delta, then fx minus L is less than epsilon. That's our precise definition. Our previous definition, fx can be arbitrarily close to L, given that x is close enough to A. Okay? Try to compare the two. Do you see the advantage of this thing? Number one, we avoided to use something subjective like enough, like arbitrarily. Okay, we'll avoid it. Second, we turn something which we can only talk about, we kind of talk about, the other people kind of understand what you're meaning, into some computation or calculation. Because now you actually clearly you have a formula to look for. You need to look for delta. And that delta equals epsilon over 3 last time. Okay? So you can actually start to take calculations on the definitions, which is way better than just saying it. This time, everybody can trust the calculation and there's no confusion. You do it, some people in China does it, some people 200 years later does it, they will still receive the same answer. Okay, that's the advantage. So finally, I can give you an idea of how to say this about limit x goes to a, fx equals infinity. What do you mean by that? Think about it. It's basically for any number m bigger than 0, there exists a delta such that if x is close enough, which means less than delta, then fx is bigger than m. You name any number m bigger than that, that's the same way to say it's infinity. All right. Okay. Any questions? Otherwise, the section is over.
Thank you.
Cool. Please stay if you have any more questions. Otherwise, the section is over. Feel free to leave. Adam.